The bottom of Lake Jackson is visible right now, not from a boat, not from a drone, on foot. You can walk out to the center of what used to be one of Florida's most celebrated lakes, stand where the water was 15 feet deep, and look down into a hole in the earth that is still draining. That is not a description from 6 months ago. That is what the site looks like today. The sinkhole is still open. The lake has not returned. And the system beneath it, the ancient limestone network that first swallowed 12 billion gallons of water in a single event last November, is under more stress right now than at any recorded point in modern history. This is the part of the story that the headlines stopped covering. The initial drain made national news. The photographs of a 4,000-acre lakebed turned to cracked mud went everywhere. But the cameras moved on. The situation did not. What has developed in the months since the drain event is not a recovery story. It is a deepening one. Lake Jackson sits on the northern edge of Tallahassee, Florida. For most of its documented history, it was considered one of the finest bass fishing lakes in the entire southeastern United States. It attracted competitive anglers, migratory birds, and research scientists in equal measure. Bald eagles nested along its shoreline. Ospreys hunted above its surface every morning. Rare aquatic grasses grew along its shallows. It was classified as a Class 1 Outstanding Florida Water, the highest environmental designation the state issues. It was not just a lake. It was an ecosystem that had been functioning in various forms for thousands of years. It has drained before. That is the detail that tends to stop people when they first hear it. Lake Jackson has completely emptied through the same sinkhole system at least 7 times in recorded history, with evidence of additional drain events going back further than documentation reaches. The mechanism that caused last November's collapse is the same one that caused the events in 1999, in 1982, in the 1930s. It is called a Porter Sink, and it sits at the southern end of the lake, directly above a fracture point in the limestone shelf that forms the lake's floor. When conditions align, when the water table drops, when the limestone dries, when the structural pressure increases, the plug gives way, and the lake drains into the aquifer below. But here is the detail that tells the real story. Every time it drains, it does not drain the same way. The 1999 drain event took roughly 3 weeks to complete. The 1982 event was slower. Last November's collapse happened over a matter of days. The rate is accelerating, and the reason for that acceleration is sitting in plain sight at the bottom of the lakebed right now. Still widening, still open, still pulling at whatever moisture the soil around it still holds. The limestone beneath Lake Jackson is not solid. It is karst terrain, which means it is riddled with fractures, caves, conduits, and voids that were carved out by centuries of water moving through soluble rock. When water is present, it fills those voids, stabilizes the surrounding material, and maintains a kind of equilibrium that holds the lake floor together. When the water disappears, the limestone is exposed to air. Exposed limestone in a karst system does not stay stable. It dries, contracts, and fractures further. The fractures create new pathways for the next water cycle. The next cycle drains faster because the pathways are wider. Then those pathways dry out again and crack wider still. This is not a theory. It is the documented behavior of karst systems across Florida, across the Caribbean, and across every region of the world where limestone meets groundwater. What makes Lake Jackson unusual is that it is one of the few places where this process is visible above ground, in real time, at a scale large enough to photograph from the air. The sinkhole that drained the lake last November measured roughly 20 feet across in the initial reports. Current assessments place its diameter significantly larger. The walls have slumped, the throat has deepened, and the surrounding lakebed, which had been muddy and soft in the days immediately after the drain, has now baked hard under months of exceptional drought. the worst drought category that exists on the National Drought Severity Scale, leaving a surface that looks less like a dried lake and more like the floor of an ancient ocean. The drought is the second layer of this story, and it has not improved. The exceptional drought rating that was in place when the lake drained has not been lifted. In fact, the conditions across North Florida have worsened in the months since November. Rainfall totals for the region have remained well below historical averages. The aquifer levels that normally feed the region's springs, rivers, and lake systems have continued to drop. This matters for Lake Jackson specifically because the lake does not refill from surface runoff alone. It depends on the regional water table rising high enough to push water back up through the same karst system that emptied it. If the water table stays low, the lake stays empty. And right now, the water table has nowhere near enough pressure to reverse the drain. There is also a second condition at play that complicates the refill timeline further. The springs that historically contributed fresh water to the Lake Jackson Basin are under stress. One of the primary feeder springs in the northern part of the watershed has shown reduced flow rates over the past 2 years, a trend that researchers have connected to both declining aquifer levels and increased withdrawal pressure from nearby development. A spring that runs at reduced flow during a drought does not just deliver less water. It changes the chemistry of what it delivers. Reduced flow concentrates certain minerals and increases the temperature of the water that does move. Both of those changes affect the biological communities that depend on the spring outflow. And in a lake system that is already empty, every contribution matters. Docks that were built at waterline now sit 15 feet above dry ground. Boat launches end in cracked dirt. Fish that were stranded when the drain happened decomposed into the lakebed mud months ago, their outlines still faintly visible in the hardened surface. The smell that accompanied the initial drain, hydrogen sulfide rising from the exposed organic material, has faded. What replaced it is the smell of nothing, a 4,000-acre absence. And this is where it gets worse. The biological consequences of an extended dry period in a lake like this are not simply a matter of waiting for the water to return. Lake Jackson's ecosystem was not built to recover from emptying the way a bathtub refills. It was built to recover from emptying the way a forest recovers from a fire, slowly, in stages. With the specific conditions of soil chemistry, water chemistry, temperature, and species availability all having to align before the system begins to stabilize. The aquatic grasses that once covered the shallows and provided spawning habitat for bass, bluegill, and dozens of other species took years to establish. They are gone. The sediment layers at the lake's bottom contain decades of accumulated nutrients that supported the base of the food chain. Those sediments are now exposed to the air, oxidizing, releasing stored carbon, and restructuring in ways that will alter the lake's chemistry when water eventually returns. The migratory birds that used the lake as a stop on the Atlantic Flyway are not waiting. They have moved on to other water bodies. Whether they return depends entirely on how quickly the lake recovers. And how quickly the lake recovers depends on the aquifer, the rainfall, the sinkhole, and the fractured limestone that connects all of them. Researchers who study Lake Jackson do not use the word recovery lightly. The lake has come back before. That is documented. But the conditions under which it came back were different each time, and the baseline it returned to was different each time. The 2000 recovery, after the 1999 drain, produced a lake that scientists described as measurably different from the pre-drain lake. Different plant communities, different sediment profiles, different fish population distributions. A lake with the same name and the same shoreline, but not the same organism. What comes back this time will be shaped by how long the drought holds, how wide the sinkhole has grown, and whether the limestone beneath has cracked to a point that reduces the lake's capacity to hold water at all once refilling begins. That last possibility is the one that sits at the center of every serious conversation about Lake Jackson's future. If the sinkhole has widened enough, if the fracture network beneath the lake has expanded through the dry period to a point where the natural plug that forms during high water table conditions can no longer seal effectively, then Lake Jackson does not just refill slowly. It refills incompletely, drains again more rapidly, and enters a cycle that makes permanent open water increasingly unlikely. This is not speculation about a distant future. The historical data already shows the drain events becoming more frequent. The interval between the 1982 drain and the 1999 drain was 17 years. The interval between 1999 and the 2006 partial drain event was 7 years. The pattern does not have to be linear to be alarming. The underlying geology is not recovering between events. It is compounding. The Florida Department of Environmental Protection maintains monitoring equipment around the Lake Jackson Basin. Water table readings are still being taken. The sinkhole has been assessed by geological survey teams. None of those assessments have produced a refill timeline. None of them have produced a guarantee. The official language used to describe the situation is careful, measured, and notably free of prediction. What it does not say is almost as telling as what it does. There are people who have lived on Lake Jackson's shoreline for 30 and 40 years. They built their homes there because of the water. Their property values are attached to the water. Their mornings were defined by the sound of the water. They are still there, looking out at the lakebed, watching the sinkhole that is not closing, waiting for a rain pattern that has not come. Some of them say they have seen this before, and they are not worried. Others say they have seen this before, and they are more worried than they have ever been. The difference between those two groups is not geography or property value. It is whether they have spoken recently to someone who studies limestone for a living. The ones who have are not waiting to see what happens. They already know that what is happening underground is not visible from the surface. The widening is not audible. The new fractures do not announce themselves. By the time there is something to photograph at the surface, the process below has already been going on for months. Lake Jackson is still empty. The sinkhole is still open. The drought is still rated exceptional. The limestone is still drying. The question that researchers are now sitting with is not whether Lake Jackson will return. It probably will. The question is what it will return as, and how long it will hold the water once it does.